So this tiger on this rock is going to leap horizontally at an initial speed of 3.5 meters per second. It's going to land somewhere at the bottom. It'll make a parabolic path. It'll land somewhere there. We're asked to find how far from the base of the rock will it land. I'll label that as an x displacement. An x displacement. So if we go and do the algebra, we have, this is a projectile, so we'll have some vertical information. We'll have some horizontal information. Just going to organize the information first. So vertically, the displacement of the tiger, delta dy, is going to be 6.5 meters down. Okay, the displacement is down. The acceleration is going to be due to free fall, 9.8 meters per second squared down. And the initial velocity vertically, v1y, is 0 meters per second. That's because the jump is totally horizontal. We're going to use this information to find out the time that it takes a tiger before it hits the ground. So since it's free fall, it's uniform acceleration, so we can use the uniform acceleration formulas. The one that will work for us is number 3 from the list we have in our classroom. That's the formula there. The initial velocity is 0, so I can cross out that term, and you have to cross out the whole term. There will not be a delta t there with it because it's being multiplied to 0. 0 times anything is 0, so the whole term goes to 0. So now I'm isolating for time, which is on the right side of the equation. I'll leave it on the right side of the equation. Start by getting rid of the half. That'll be a multiplication by 2 to the other side. And then getting rid of the acceleration, which is done by dividing. And then getting rid of the exponent of 2, which is done by square rooting. We'll have plus or minus the square root of all of that. I know right away that the negative sign is going to be inadmissible because we're solving for time here, and it doesn't make physical sense for the time to be negative. So it'll just be the positive value of the square root. I'll fill in the values, 2 times 6.5 divided by 9.8, giving us a time of, get my calculator going, so I'm getting 1.152. That's rounded. I kept a couple of extra digits, but I'm going to underline 2 significant digits. So the tiger is going to hit the ground in just over a second, and we can use that information in the horizontal section. It'll be in the air for 1.152 seconds approximately. And we know the horizontal speed, Vx, or the horizontal velocity of the tiger, Vx, is 3.5 meters per second. So I can use those two things to get the horizontal displacement, delta dx. That's just going to be the horizontal velocity multiplied by the time. The displacement equals velocity times time. 3.5 times 1.152. So in my calculator, I still have my answer from previous in my calculator, so I'm not going to clear it. I'm just going to continue. So I take that answer that's in my calculator, I hit multiply, 3.5 equals 4.0. and I'll give a direction of forward. So the tiger is going to land 4.0 meters away from the base of the rock.